Welcome to our session on maintaining data confidentiality throughout the artificial intelligence lifecycle. Today we are exploring how secret information is handled and potentially mishandled across different technological environments. As an auditor or risk professional, understanding this pipeline helps you pinpoint exactly where a company might accidentally leak sensitive customer information during system development. You can use this knowledge directly in your daily job to assess if a vendor's new tool is handling your proprietary business information safely before your company signs a contract. Our first major concept is the origin point of the information, referred to as the data source. This is where the initial information for teaching the artificial intelligence is collected. To protect secrets, organizations often restrict exactly where these ingredients come from, ensuring people only see what they absolutely need to see for their specific job. Professionals use techniques like obfuscation, which is simply scrambling the information so it cannot be read, or encryption, which is locking the information with a mathematical key to keep things private. However, there is a massive hidden risk here regarding metadata. Metadata is simply data about data, like a digital tag showing who owns a file or its specific security classification. When you extract information out of its original secure home to use it for an artificial intelligence project, those digital security tags, access controls, and protective masks often get left behind. Imagine taking fresh water from a clearly labeled, purified bottle and pouring it into an unmarked bucket. The water is the same, but nobody in the room knows if it is safe to drink anymore because the crucial warning label was completely lost in the transfer. Next, we move to the massive storage pools, commonly known as data lakes. A data lake is a giant digital warehouse where all types of information are aggregated or brought together into one central location so they are easier to use for modeling. This includes neatly organized spreadsheets, which we call structured data, alongside messy, random emails and documents, which we call unstructured data. The major audit concern here is commingling. Commingling is the dangerous practice of mixing highly restricted, top-secret files in the exact same storage area as everyday public information. If the strict access controls from the original source are not preserved in this new giant pool, sensitive secrets that were once restricted suddenly become widely available to all users. Think of it like putting highly confidential corporate merger plans in the same filing cabinet as the company cafeteria menu. If every single employee has a key to that cabinet just to see what is for lunch, they now accidentally have full access to the secret merger plans too. Once the information is stored, scientists need a place to work with it, which brings us to the data exploration and training platforms. These are interactive workspaces where engineers pull data out of the lakes to experiment and actually train the artificial intelligence. In the industry, you will frequently hear these workspaces referred to as Jupyter notebooks or SageMaker platforms. Jupyter notebooks are popular interactive digital documents where programmers write code and analyze data, while SageMaker is a specific cloud service built by Amazon to help developers build and train models. The risk here is that data of many different security classifications might be downloaded and stored directly inside these notebook files. It is very similar to a bank teller taking your highly confidential loan application out of the heavy vault and leaving it sitting wide open on their personal desk. The heavy vault is perfectly secure, but the temporary workspace where the actual work happens might be completely vulnerable to wandering eyes. Now we must discuss a new form of database called a vector database. A vector database takes human formats, like written documents, pictures, and audio, and processes them entirely into vectors. A vector is just a complex mathematical representation or a long list of numbers that captures the core meaning of that file, stored alongside its metadata. Because the original text or raw data is completely gone and not stored in these databases, traditional security locks do not work anymore. Organizations must consider totally new access control models to protect these mathematical files. For example, access might be controlled via a specific user attribute, a search index, or the exact query being asked. Imagine translating a sensitive legal contract into a highly complex, secret numerical code. Even though the normal English words are erased, the sensitive meaning is still fully intact. You cannot just put a normal padlock on it anymore. You need a special decoder ring to control exactly who gets to search or read that secret numerical language. Finally, we arrive at the end of the journey, known as artificial intelligence system production. This is when the model has been fully trained, developed, and software is implemented to use the model in the real world. To function, this live system often requires taking live production data and running it through automated data prep pipelines. A data prep pipeline is just a digital assembly line that transforms the information so it is ready to be input into the model. The model then digests this information and provides the resulting inference results, which is just the technical term for the model's final prediction or answer. The critical audit point here is that depending on the data sources needed for these answers, all the strict data classification and handling protocols must be implemented in the live production system as well. It is identical to running a busy restaurant kitchen during the dinner rush. Ingredients are constantly being chopped, cooked, and served at high speed. You have to ensure that strict food safety protocols are followed at every single step on the chaotic cooking line, not just when the food was sitting quietly in the refrigerator overnight. Let us do a quick recap of our journey. We tracked the flow of secrets starting from the highly restricted data sources into the massive, mixed storage pools of data lakes and out onto the temporary exploration platforms like Jupyter Notebooks and SageMaker. We also explored how modern mathematical storage systems like vector databases require new types of locks, and how live, operational software must maintain strict handling protocols during system production. To ensure you are fully prepared for your exam, all the important topics and concepts from this session are covered in the multiple choice questions on RooCloud.com. I highly recommend you log in and solve the chapter-wise questions to reinforce your learning before moving on to the next session.